In this video, we're going to introduce the concept of factoring. To factor something means to rewrite it as multiplication. In example A, we want to break the following expressions down into their individual factors. So part 1, we have x squared. To break x squared down into its individual factors, we'll break it down into x times x, because x squared simply means x times x. Similarly with 15, we could rewrite 15 as 3 times 5. By having taken x squared and 15 and rewritten both of them as multiplication, we have now factored them. In part 3, we want 10x to the third, y to the second, and we want to break it down to its individual factors. When you work with numbers and variables, you want to think about them separately. 10 is the same thing as 2 times 5, so that's factoring the 10. X to the third means x times x times x. And y squared means y times y. So 10x to the third y squared can be broken down into 2 times 5 times x times x times x times y times y. In part 4, we want to break down 12x y to the fourth. 12 can be broken down into 3 times 4. And x is an x, and y to the fourth means there are 4 y's. While we have rewritten this as multiplication, we have not broken it down into its individual factors. The 4 can be broken down further. So 4 is the same thing as 2 times 2. So to break 12x y to the fourth down further, we could rewrite this as 3 times 2 times 2 times x times y times y times y times y. In part B, we're not asked to factor, but we're actually asked to multiply. We want to multiply 3 times the quantity, x plus 7. In this situation, hopefully we recognize we need to distribute that 3 to both the x and the 7. So if I'm going to multiply this out, 3 times x is 3x, and 3 times 7 is 21. Factoring is exactly the reverse of what we've just done. Instead of distributing the 3 to the x and the 3 to the 7th, when we look at part C, we want to reverse the process. So we're going to take 2x minus 8, and we're going to actually be asked to factor it. The first step in factoring any polynomial is to look for what is common to each of the terms. The first term is a 2x, and the second term is an 8. Technically it is a negative 8, but I'm going to ignore the negative for the moment. 2x is the same thing as 2 times x, and 8 is the same thing as 2 times 4. I can see already that both of these terms have a common factor of 2. So my first step of factoring 2x minus 8 is to rewrite this as 2 times x minus 2 times 4. Normally we don't write that step out, but we're doing it right now to explicitly show how 2 is a common factor to both of those terms, and how we're going to essentially undistribute it. Instead of doing distribution in the usual manner of distributing the 3 into the parentheses like we did in part B, we're going to undistribute it. We're going to pull that 2 back out of the parentheses. And if we undistribute the 2 from the 2x and the 2 times 4, it would leave us with x minus 4 in parentheses. One of the nice things about any factoring problem is it can always be checked. The way to check it is to take your answer, in this case 2 times the quantity x minus 4, and distribute it back out. If I distribute that 2 back into the parentheses, 2 times x is 2x, 2 times negative 4 is negative 8, it does check out. It is important that you separate your check from your original factoring work. You want to make sure it's clear to anybody looking at your work, whether it's another student or your teacher, that you know where the factoring ended and where the checking began. Again, factoring is simply the process of taking something that is not multiplication, but breaking it down into its smaller pieces and rewriting it as multiplication. And the first step in this process will typically be to find and then factor out the greatest common factor.